We're doing some summation arithmetic, modulo 3. So let's just briefly review what we mean by modular arithmetic, or mod 3 in this particular case. 16 is congruent to 1 mod 3. Now you can think of it, you can just say it leaves a remainder of 1 when you divide 16 by 3. And another way of just stating it, it's equivalent, is just this implies, I guess it's if and only if, to 16 is equal to 1 plus some multiple of 3, which would be 5 in this case. So 1 plus 5 times 3. So that's an equivalent way to talk about what we mean by this symbol 16 congruent to 1 mod 3, or this expression. But that's 5 times 3 there. 5 times 3 is 15 plus 1 is 16. 1 is the remainder. And also just this statement right here is absolutely equivalent to this statement right here. Okay. Now we'll use that truth in just a minute here. We're trying to find a value of n in the set 0, 1, 2. Now notice those are the 3 remainders when you divide by 3. We could pick other sets, like we could pick 3, 4, 5 if you wanted, or any other 3 numbers that are congruent to either 0, 1, or 2. But in any event, notice that this left-hand side here is a big, there's 200 summands here. Notice that the little trick here, 208 minus 9 plus 1. Okay, that's the actual number of summands. Okay, and what is that? That's 208 minus 9 is 1. So wouldn't that be 200? Yep, that's equal to 200. All right, 200 summands. It's a little bit different than you might think. It's not 208 minus 9, which is 199. It's 208 minus 9 plus 1. Okay, so there's 200 summands there, and that would be very tedious to add all this stuff up manually, even though the cubic terms cancel out. So we got to look for a better way than that. So we'll do the difference of 2 cubes result, and I did some of it here for you. Now notice what's going to happen right here. You'll get the cubic terms canceling, and then you'll have 3i squared. 3i squared, and then what do we have? Minus 3i. And a plus 1. But what makes this thing tick is that you can factor out a 3 here. You can factor out 3i, in fact. So you get 3i times, what do you get? I plus, or I minus 3. But what we have here is a multiple of 3 plus 1, right? Okay, so that means that this object, or it's the summation of this object, this summand is just equal to a multiple of 3 plus 1, right? So that means it's going to be congruent to the same summation, except we can just replace this entire difference with 1. Okay, so we got summation I equals 9. To 208, the lower and upper limits of the summation. And it's just a bunch of 1s, right? Okay, but we already know that that is equal to, summation of a bunch of 1s is equal to 200. It's very convenient to have a constant summand of 1. But notice that 200, let me just go here, 200 is equal to 3 times 66 plus 2. I'll write it 66 times 3 plus 2. Okay, so we have it in that form, and that means it has to be congruent to 2. Okay, so that's the answer, folks. If I hadn't made any mistakes here, 3 times 66 is 198 plus 2 is 200. And so it's in that form of you know, a remainder of 2 and a quotient of 66. Okay, and so the 2 functions as the remainder, and that satisfies the congruence. So, answer to the question is 2. Okay. That's all. Thanks for viewing.